I love listening to it.
Kane Sims.
Kane Sims.
Kane Sims, the one and only
Britain's finest, Mr. Kane Sims.
Dustin Coates.
I like it when you guys are together and talking about boys.
Without further ado, welcome to the show.
Nearly went twice there.
Yeah, let's go again. Give it an encore.
Let's do it. Hello, everybody. How's it going?
Hi there. Hi, Kane. Hey, Dustin. Hi, everyone.
Hello. How's things, Dustin?
They're going all right. How about you, Kane?
Yeah, all right. Lockdown 3.0, broadcasting live still from the isolation, incubation, ideation, broadcasting station to the nation. Yeah, starting to crack up a little bit, going a little bit stir crazy. Can't see the end in sight, but other than that, loving it.
And Nico, how's everything going with you? Nico, can you hear us?
Where are you guys based, actually? Kane, Dustin.
Say again?
Where are you based? Where
Oh, right. So I'm just south of London. Dustin is in your native homeland in Paris.
No
Yeah.
way. Brilliant. Okay.
And how about-
well,
how
I'm
about
in
you?
Switzerland, and we've just had a long snowy day with blizzard, and it's getting crazy cold. So I'm happy I'm inside now.
Good. Just checking. Dustin, can you say something? I just want to check Nico's hearing you.
Yeah, can you hear me, Nico?
No, I'm not actually. I'm not hearing anything.
Oh, you're not hearing Dustin. Are you hearing me?
Yes.
And you're hearing me, Kane?
I'm hearing you.
It's okay. I'm not saying
Something's
anything
deeply
interesting.
wrong.
Right. Okay. Let me try this. Hold on. Give me a sec. I'm gonna turn you both off for a minute, and then we're gonna try it again. All right. How's that?
Yeah, can you hear me, Nico?
Hello?
No, it doesn't
No.
look like it.
Interesting.
I can't hear
Okay.
anything.
Can you hear me, Nico? You can hear me?
No, it doesn't seem like it.
No? Right. Okay. This is interesting. Hold on.
Oh, yeah.
Hold on. I want to just double check. Oh no, but you can hear me though, Dustin.
Yeah, I can hear you just fine.
Okay. We might need to sort this out. So I'm trying to figure out whose end it's on. So Nico can hear me, Dustin can hear me, I can hear Dustin, but Nico can't hear Dustin. That's what it is?
Maybe I'll just relay all my questions through you, Kane.
Well, let's try. that could get
I'm not sure if
complex.
you can hear me, but I'm having trouble hearing you.
All right. Okay. So I think it must be on Nico's side. Do you want to try leaving and joining again, Nico? He can't hear me. Hold on. I'll type it to him. Try leaving and joining again. We were just, funnily enough, ladies and gentlemen, we were literally just talking about how stable this platform is, Dustin.
Yeah.
Interesting. We'll wait for Nico to come back. I'm sure he'll be fine. I'm sure he'll be joining us in a moment. And in the meantime, welcome to the show. Welcome to VUX World. This is the show where we delve deep into all nooks and crannies of conversational AI and find industry practitioners to figure out how they do what they do so that you can do what you do better. And every now and then we have a bit of a deep dive into a technology type and try and understand a little bit about the various technologies at work in the conversational AI space. We've had real deep conversations with the likes of Catherine Breslin, talking about what is speech recognition and delving under the hood of how that works and stuff like that. And today with Otto, we're going to kind of have a bit of a similar conversation, really, and find out a little bit about sentiment analysis and about how you can understand, get actionable insights from your speech data, from customer speech data, and use that to improve customer experience. Let's see if Nico can hear us again. Can you hear us now, Nico?
I can hear you, Kane.
Can you hear me?
Oh, brilliant. It was working.
All right,
Can you hear Dustin?
Yes, both.
Okay.
Right, fantastic. Okay, now we're rolling. Now we're ready to rumble. Thank you for joining us, everybody, and thank you for joining us, Nico. Pleasure to have you on. Let's kick off. Do you want to tell us a little bit about yourself and a little bit about Otto?
Absolutely. Say myself first. So Nico, French citizen, have been living in Switzerland, mostly in Switzerland for the past 15 years now, on and off, because I've lived in a number of places, from the steppes of Mongolia to the Kalahari Desert and the East and West Coast in the US. I'm an engineer by training. I got educated or trained in building robots and real-time systems, which I think is really interesting. But quickly thereafter, I realized that it wasn't really what I wanted to do. I didn't want to only build things. I wanted to understand things. And that drew me to fundamental science. So I got into the science of interactions between humans, between individuals, between humans, animals, humans and animals, and really modeling how this goes. What I'm really interested in, I think, is what motivates us to do the things we do. Everything we do, the decisions we make, they're socially motivated. There are two things. There's the social network of interactions, the structure and dynamics of the network. So if you're my friend, for example, I'm more likely to believe you or go with you to a restaurant. And so these are the things that I did for a long time, basically studying social networks. The thing that I couldn't do when it was like 10, 12 years ago, when I was doing my studying for my PhD, was actually studying the microscopic or short-term interactions between people, and especially voice interactions, because basically, if I make a decision now, if you tell me a story and I believe it, it's going to have to do with what you say and of course, how you say it. So this is something that I find deeply interesting and fascinating to explain how we behave, how we think about things, how we form opinions. And that's been sort of the guiding thread for my work and research for the past maybe 15 years now. So fast forward, a few years after doing sort of stopping doing research, I was in data science and machine learning, AI, which is really my core focus. Working with a company called Hyperloop Transportation Technologies, and leading their AI team. So really a super interesting project, which drew me to California, where I met incidentally, my co-founder Theo Borschberg, who then was an entrepreneur in residence at the Stanford Research Institute, so SRI International, out of Menlo Park, and he told me, "Hey, look, I have this really cool technology which allows the extraction of emotions from the voice of a person in real time, and I want to build something on top of that technology." And actually, I think he said, "And I want to do it with you." And so I had to give it a hard thought for a few days, because I was working on something really interesting, but that had the potential to be even more interesting. And I said, "Yeah, sure, let's do it." And thus, in the spring of 2017, we decided to build Auto. Before you ask the name, so before you ask what the name means, I'm going to tell you. It means nothing. It means nothing. Actually, it was a name that Theo was looking for, something that should be easy to say. Little did we know, though, that one of our first employees had a wife who was from Japan. And it sounds like I'm digressing, but I'm not. Because one day he said, he was leading our AI efforts then. He was leading, "Hey guys, Auto, the name, it's such a good idea, right? Like, how did you know?" And we said, "What do you mean? How did we know? We didn't know anything." Turns out, Auto, I think, if I say right, means sound in Japanese. And Auto, wow, as a company, as an endeavor, as an enterprise, we focus on extracting meaning from sound. So there's a name, even though in the beginning it wasn't for that.
How's that for serendipity? Interesting. So tell us then what Auto does. When you say you extract meaning from sound, what does that mean, and how does it transpire? Well,
you know it from interacting with your relative and family. I'm not going to say your partner, but from everyone. Often it's not about what you say, is how you say it. And there's a large fraction of the meaning, the information that we get. So this social network of interactions, there's a large part of that, of the information that is not in the words, but really in the tone. If you go back to something we quote often, it's called the Merabian Formula from Albert Merabian, so a behavioral psychologist at UCLA back in the 20th century, I think 70s, 60s, 70s, he did lots of experiments on how decisions are motivated and what are the different factors and their respective weights in a decision. And when it comes to affective decisions, so if I'm going, decisions that have to do with the affect of a person, if I'm going to believe you, if I'm going to like you, we've had no interaction before, but whether I'm going to like you, whether I'm going to buy what you're selling, that has a lot more to do with the intonation than the words themselves. And there's this formula which I like because it's very easy to remember, and it's the 7-38-55 rule. So when it comes to an affective decision, 7% of the weight, or 7% of that decision will have to do with the words, what is said, 38% with the how, the intonation, how it is said, and 55% with the body language. So right now, if you're watching the stream, you can see me, and you can hear me, and you can understand what I'm saying, but what you see and what you perceive from my tone are much more important than what I'm saying. And if you restrict yourselves, say, to a voice-only settings on the phone, we work with call centers extensively. On the phone, then the ratio becomes basically 20-80. And so far, speech analytics, speech to text, has mostly focused on taking an audio stream in real time or offline, running it through a speech to text system, so an ASR, automatic speech recognition system, and doing then analytics, so natural language processing, modeling on top of the words. But this is very, it's so lossy. There's a world of difference between hey Kane and hey Kane, and it would be transcribed as the exact same two words. But there's no way that you can transcribe a hello, a greeting, with one word. In the same way, laughter is super important. It's something that we convey to express, that we express to convey, friendship, to convey amusement, to say, hey, I'm part of the conversation, I'm having a good time now, as you are. And often, most ASR systems do not transcribe laughter. Those that do have a special token, that's laughter. So basically, laughter becomes a word. But there's nothing like, timid laughter, booming laughter, nervous laughter, etc. So all of this is information that is lost. So ASR, speech to text, is very lossy. You lose a ton of information. It is noisy. Often it doesn't work. I mean, and it's got to the point where it works quite well in some settings, very well in few settings, but not very well in many settings. So it's still imperfect, and it's also expensive. It is computationally expensive because you have to stick a large language model on top of your signal processing front end. And basically, if you remove the language model, you remove much of the complexity, you still have a system that is quite capable in its own, and it's sort of what we've built. So we've built a system that takes as input, like a speech-to-text system, that takes as input a stream of audio, and then dozens of times per second extracts lots of information. We call them features and properties of the audio that translate into latent speaker states and properties of the speaker, how they feel at any point in time. So that's the base technology behind Otto.
Wow. There's quite a lot in that. And one of the best examples of what you were saying there in terms of how something is said is more important than what is actually said. It always makes me think, because we've come across this, and a few people have mentioned that on the podcast. And the best example of that is when, I don't know if you've seen the Friends episode. Do you watch Friends, Dustin? Yeah, no.
It's been a while.
Nico?
It's been a while.
It's been a while, fair enough. Well, it's obviously etched in my brain. There's a scene in Friends where they all go to watch Joey in a play, and the play is absolutely terrible. It's like the worst play that you could ever imagine. And afterwards, Joey ends up having a conversation with somebody, and it turns out that they're an agent, and they ask if he wants to come and audition for another part. And Joey goes back over to the group and he says, I've just been talking to an agent that want me to audition. And Phoebe says, based on this play? And he looks at him and says, yeah, and everyone looks at Phoebe as if to say, like, didn't you like it? And then she turns around and says, based on this play, like that. So she says the exact same words, but totally flips the meaning just by expressing it differently, which is, it's one of my favorite things. There's a few things I wanted to kind of dig into in that. When you were saying that the Auto is able to understand a lot more than maybe a speech recognition system, NLU. Gianna loves Friends. So do I. So I must be on my own. But at least we're not on our own now. One of the things that I was be interested in is if you can understand various parts and various portions of incoming audio, what do you then do with it, or what can be done with it? Because you mentioned call centers. You know, if you're working in a call center, and you're listening to the person talking, you're able to see some kind of data about the way that they're speaking or whatever it might be. What kind of things does that allow a call center agent to be able to do? It sounds as though they might have to think fairly quickly to be able to act on it. Is kind of what I kind of want to get to. But can you just describe some of the things that being able to understand the context or the sentiment or the emotion behind the audio, what does that actually enable a business or a brand to be able to do?
Absolutely. So I'll tell you about the use cases that we had in a call center space, and we still have, but also then later the sort of the broader set of use cases that we've developed and realized we could do after. So we started by building a tech stack on top of that technology from SRI International, and realized that then all of a sudden we could tell how people felt, their energy from their voice. The next question was, of course, so what do we apply this to? We were not that clueless. We had the plan of deploying this into the in a call center environment, and then we used it mostly for two things in the beginning. And the first one is tone coaching for call center agents. The first customer we had actually 3 years ago is called ACD Direct, and they have about 1,000 call center agents in the US. And these agents mostly receive calls, take inbound calls of people who want to make donations to charities. And the most important thing is for these agents to sound good, to sound engaged and compassionate, and energetic, etc. And that's something that you can't do with a normal system. Usually you have to have a human essentially listen to some of the conversations. It's quite expensive, of course, to implement, and then give a score, a rating to the agent, and then in their monthly review or something, they are being told, okay, well, you could try and sound a bit more, energized, etc. What we did is that we built a system in which agents can self-learn, so learn by themselves how to sound good in a conversation. We've made it super simple. So in the backend is actually quite complicated because there was lots of streaming, lots of AI processing, etc. But the product itself is really simple. It's a small widget that lights up green. And so my tone, for example, now I'm working on it. My tone is really good, right? And I'm modulating my voice, etc., so that it sounds enjoyable. Could I do this 10 hours a day? Not sure. So after a while, I would start sounding a bit more tired, obviously, and not super pleasant, basically, in the conversation. And this is when the widget would light up red and give kudos, like encouragement, saying, "Hey, well, remember to watch your tone, smile when you speak, etc., etc." And this worked really well because first it was simple. It was very simple to use for the agents. But also they didn't have the feeling that there was a big brother AI watching them. It was something that they could have on their computer, on their screen, and it was giving them personalized advice to sound better. But there wasn't a manager in the loop, so that they could get better on their own. And that's something for which we had quite a bit of success, and it worked well. And we thought, okay, but if we have this, we can also apply it to the customer side of the conversation. And as you know, of course, customer experience is a very large market. And it's very difficult to know often if an interaction has been positive or negative. And that's why we have NPS, of course, that allows a brand to understand how happy or angry, satisfied or dissatisfied its customers are. However, there's no way to do this in real time often. So what we built is a system based on the emotions, the tone of a customer that measures the tone of the voice and predict how likely it is that this customer will be dissatisfied after the call. And we've trained that system with a large number of conversations associated with satisfaction labels. So, when you get a text message at the end of a call with a hotline, and it says on a scale from 1 to 5, how satisfied are you? So basically that's our training data. And we did this for hundreds of thousands of conversations, and we got to build a pretty good picture of how someone sounds when they're not happy. And that's information that right after the call basically would inject into our customer CRM and say, well, we think there's a high likelihood that this customer wasn't happy, so that they could be called back right away. So these are basically the sort of the main use cases and variations around these use cases in the call center environment. And then two things happened. First, it was at the end of 2019, I think, we realized that the technology itself was very novel and mature enough to be deployed in other environments. So we decided to build DeepTone. DeepTone is the name of the technology and the platform. So we decided to build it as a platform, and at the same time, the world changed a little because the COVID crisis started, and call centers around the world shut down properly. So we went to having some business with call centers to zero business at all, and that was in March 2020. And we realized that we had to sort of broaden we wanted to do this anyway, so broaden the scope of use cases that we worked on, and that's why we built, again, DeepTone as a platform. So if you go to our website, auto.ai, you'll see you can try a demo with your own voice. You can record your voice. You can upload a snippet, and it works with any voice basically. And then we applied it to a number of additional use cases outside of the call center industry. Do you want to know about these, or should I stop digressing?
We'll get there. Yeah, we'll definitely explore that. That kind of future use cases in a minute, but it's interesting. I'm wondering, Dustin, whether I want to feed some of these podcasts through and see what my tone is like. I'm conscious of how I'm talking, but yeah, it's interesting stuff. How did you find when you were kind of rolling? I want to also, before we get onto the other use cases, I want to kind of talk a little bit more and drill down a little bit more into how it can be used in conjunction with other technologies, perhaps to automate some of this interactions and stuff like that. But how did you initially find that when you implement this on the call center to try and help coach agents in essentially how to, I suppose, be more delightful on the call, if you like? You said that they weren't as kind of, what's the word, trepidatious, if you like, because they didn't feel as though people were watching them. But how did they kind of respond to having something like that? Because I can imagine, like, for certain people, it might feel a little bit was it a little bit off-putting? Like, did you have to do some training and onboarding to kind of coach people through the fact that, hey, this isn't there listening to you and judging you. It's there as a tool to help you and the organization kind of be better. Like, how was the initial kind of rollout for those kind of use cases?
We had remarkably little coaching and training to do. I thought in the beginning, well, people are not going to like it. They will feel that like they're being watched. So we designed the product, this tone coaching widget, in a way that it would be very unobtrusive. So it just sits in the corner of an agent screen. And we also made it very clear that their conversations were not being recorded on top of the normal recording that happens anyway. And we were not actually doing anything else with the audio than simply measuring the energy in their tone and feeding it back to them. So it is a tool that they can use in order to get better. But in no way is this a tool that allows, say, managers to spy on the agents. And even though it would be possible in theory to build sort of a real-time alert system, if an agent has sounded robotic for 5 minutes, then maybe someone has to intervene or something like this. Even though that's something that we could have built, we never built it in because we wanted to keep it super simple and self-contained in a way that agents can use that again to have a sort of a sparring partner to improve their tone, except that is not something that is possible with a human because they would have to sit next to you for hours on end. And that's what we made possible with that widget.
And how much of this tone is cultural? I mean, how much does that play into it where maybe one tone in one culture has a different implication than in another? Or is it pretty global?
It's a simple question with a complicated answer. It depends how you look at it. So the first, and I have to go into the technology a little. The first thing we did was use what we call designed features, like for example the pitch of a person's voice, and compute the engagement score based on that. Quite quickly, we realized that there were differences between individuals. For example, obviously, women have a higher pitch than men, so we had to correct for gender. But then we also had to correct for language, and then we had to correct for accent, etc. And then we realized that it was becoming intractable. And so this is why we decided to create Deep Tone. The first version of the platform was called Sensei, like a Sensei master, but SAY. And it was based on these design features. But then we decided to build a platform that is end-to-end and that doesn't use design features, but learn features. It's a big thing in deep learning. You don't have to explicitly hand code what you're looking for in a signal. You can let the system learn it by itself. So this is what we call learn features. And the idea here is that if you feed it enough examples of people speaking in whichever tone, but if these people represent a good chunk of the world's population, and then it will be men, it will be women, it will be young people, it'll be old people, it'll be people speaking in tons of languages with tons of accents. If you do this, then you build a good enough generic representation of how someone sounds. And based on this, and if you train a model of, say, arousal or engagement, emotions on this, and if your base model, which we call the identity model, if your base model is trained well enough, then you're not going to have this problem. And that's why our system now generalizes to, in theory, any language and any accent. In practice, there are some languages we haven't tested on.
Interesting. It's that's interesting. That I'm kind of wondering. I can see how in the UK use cases that you explained there around the contact center, there's some interesting applications of this working. I would kind of say like in its own kind of narrow space, right? So an agent is talking. It's monitoring the conversation or the tone of the conversation, rather. It can tell the agent, you can perk up a little bit, cheer up. And then at the same time, it can be used in the call to then start trying to predict the success rate, if you like, as far as customer experience is concerned within that call. I'm wondering whether have you any examples, or is it something that you're thinking of, or have you done it yet, whereby this data can be used in conjunction with some other technology to then be able to dynamically change an interaction. So rather than telling an agent, a live human, hey, now you need to kind of perk up a little bit, or after the fact saying to the contact center, hey, now you should call this customer back because they weren't very happy. Have you done any work whereby this technology is working in conjunction with like a conversational AI, for example, who can, when the tone gets to a certain level, or it detects that the conversation isn't, the customer isn't a happy customer or whatever, it can use that data to then automate some of those responses? Is that something either happening or looking like happening? Yeah,
so we have a couple of projects in that space. What I'm thinking about is, in particular, voice bots. So you're calling to buy a ticket to the game, and depending on how you say, I want to buy a ticket to the game, there's actually many things that can happen. So if you speak normally, you say, hi, I'd like to buy a ticket, then maybe you have normal, you're assigned to the normal dialogue flow. But if instead you speak with a very high speech rate, without any pauses, and with a tone that is slightly irritated, you say, I don't know, ticket game now. And it was, slightly irritated. I'm not sure if that's a good example, but then you might be assigned to a different queue. You might be given higher priority if your case is going to be handled by a human agent, or there will be less questions asked and more things guessed in the ticket reservation, ticket booking or purchase process, because we've identified that you don't have tons of time and you want things to go fast. Whereas if you sound like delighted, if you sound like you have tons of time, then maybe more questions will be asked, and then we'll be able to personalize the experience more. So we have a couple of projects in that space, nothing in production yet, but a couple of projects on the personalization of voice bots, conversational agents to the tone of the conversation.
I can see that being useful, Dustin. If you hear someone, who's fuming, being able to just sometimes rather than even handle it, just escalate it, or if you hear someone who is unhappy about whatever, then there is the tone of the bot can adjust and kind of try and be a little bit more gentler or whatever.
Yeah. It like you were mentioning earlier, what you're saying is only a very small part, and so you're missing out on a lot if you're not taking advantage of how you're saying it.
Absolutely.
Curious about how so you mentioned, like, in that conversation, when you're listening, when you're monitoring, when you're trying to determine, the kind of emotional state, if you like, of someone, what are you actually listening out for? You've said tone a few times, you've said intonation a few times. Like, what is it that you actually try to quantify within that signal that will give you the signals that this person's angry or this person's happy or whatever? What are the kind of characteristics that you're listening out for?
What are the characteristics that you're listening out for when you try and make an idea for yourself of how someone is feeling?
Good question. Let's take it in turns. Right. We'll quick fire. I'll go first, Dustin, then you go, and then we'll go, right? So I'm listening for pitch.
Oh, we're
I'm
going
sure you
really
are.
lightning.
That was supposed to be lightning.
Okay. Now I've got off track. Remind me of the question again.
So the question is, what characteristics are you trying to listen out for that will allow you to determine what kind of either emotional state or what sentiment the user has? The reason why I said pitch is because if someone's speaking really high pitch, they might be quite excited and animated, whereas if they're speaking low pitch, they might be talking from the the back of the throat and mumbling and groaning and all that kind of stuff.
Mm-hmm.
No, I'd definitely say volume. Volume's an easy one, right?
Mm-hmm. Volume is relative, though. Is volume so perceived from at a given distance, and so it's the sound energy. But in fact, you're right. Both are
What about
correct.
velocity? Is that a
Yeah, you might be
velocity?
very, very angry and speak really fast, so you just might be a fast speaker, for example. And all of these are good. They are proxies, we call them correlates, to understanding latent speaker states, so how someone feels. However, the reason why it's not very easy for you to say, oh, that's what I pay attention to understand the emotion, the how someone feels, is because it has to do. It's a feeling, right? And there's no hard and fast rule as to how to say how someone feels. And I'll use an example. If I want to characterize a cat, for example, from a bird, I'll say, well, the cat has 4 legs. He has hair, and it's about this small, whereas a bird has 2 legs and wings in general, and it looks very different. So I can do this, and I can build a rule-based system that's a cat versus bird classifier, for example, and then I show it a giraffe, and it says, "Oh, that's a cat." I'm very sure, for example, because you can't plan or for all of the possible universe of observations. However, there's another way. There's another way to capture to classify whether a cat is actually a cat, and is to capture the catness. Yeah, I'm making up a word now. The catness of an animal, the birdness of an observation, and this is what modern AI systems allow us to do. Instead of defining rules, heuristics, like we used to do, and like we used to do up until recently, in fact, to get an idea of emotions, which were based, for example, on pitch, but also as especially variation of the pitch in a person's voice. Now, these features, these properties are learned directly by a neural network, which, if it's exposed to enough data, will form a good picture of the catness of a conversation, or the happiness, the angriness of someone from their voice. And over time, this system is going to become better as you feed it more data. And it does function as a black box, because that's deep learning in the end. It's millions and millions, actually hundreds of millions sometimes, of parameters that you tune with more data, labeled data especially. However, over time, you lose the connection with what exactly it is using the properties of the voice or the cat, the animal, to characterize the animal, the type of animal, or the emotion in the voice, but you gain in accuracy. So that's what we do.
Interesting. So you don't try and say this person is definitely happy, this person is definitely sad, this person is definitely angry. You just look for enough signals that point you in the right direction at the beginning. Is that right?
Yes. We train models by giving them lots of data that is labeled. And so we have what is, to my knowledge, the largest high quality labeled data set of emotional utterances in the world, which is something that is part of our licensing deal with SRI International, with over 100,000 carefully annotated utterances annotated by humans. A person speaks in a given voice with a given emotion, and then there's 3 annotators that have to agree on what the emotion is like. And so what the neural network learns to do is to associate some properties, the somethingness in the sound, to that label, without you having to explicitly define what it is in that sample that you should call happy. So it's the same thing as not having to say, well, a cat has 4 legs and a bird has 2. It's more, well, that's a cat and that's a bird. So that's happy and that's sad. And if you show the network enough examples of happy and sad, over time is going to form a good generic representation of happiness and sadness.
Wow, interesting. You mentioned earlier on that you started off in the contact center and then you discovered other use cases beyond that. Can you tell us a little bit about those other use cases?
Absolutely. So we grew out of the call center. Many of our customers are still in the call center space, and that's something that's quite interesting. We also realized that it's a complicated space to be in, mostly because of technical difficulties. So basically, if you want to integrate with a call center, you have to make sure that your stack is compatible with theirs. And there's quite a high fragmentation in telephony systems. So in order to do a project with a new customer, often you have to understand what is their stack, the version of it, etc., and build a connector for them. So we said, okay, wait, it's easier if we build something that is very easy to integrate into a new system, and then people will connect to it. So instead of connecting to an API at a customer's or in a customer's infrastructure, we built our own API to allow people to connect to it. And then we realized that it wasn't specific to call centers. Quite early on, we had some traction in healthcare, and one of our customers is a company in Germany that is predicting the early onset of Alzheimer's disease based on speech. It's not even the presence of Alzheimer's disease. It is the onset up to 5-10 years. They can predict with a high accuracy if the disease will develop in 5 to 10 years based on many things, including how someone speaks, the dynamics of micro pauses, micro stutters in the speech, the tremor sometimes in their voice, and all these properties are things we capture that are accurately transcribed into this feature space, so many numbers many times per second, and so they're numerically captured, and they can then be injected into another modeling pipeline, another stack, in order to make a decision: is this person, is this patient at risk of developing a disease? So this is one example. And we had examples. We have applications today with so virtual private assistants, robotics, social robotics companies, and so basically anything that has voice, any system that has voice, and which would benefit from the mediation of a what I call an empathy layer in the middle to improve the communication either between humans or between the human and the machine.
Interesting. That's a good way of putting it. A nice way of thinking about that. You mentioned that the another use case was around gaming and content moderation.
Yeah.
Which sounds, we've been speaking about Clubhouse at the outset, and if anyone is on Clubhouse, feel free to join us after this. We'll be doing a kind of follow-up session over there. But you mentioned that there's applications around kind of moderation, content moderation, and things like that. How does that tend to work?
Yeah, this is really big, and it's perhaps the thing I'm most excited about at the moment. So as you heard it right, voice is booming. And people converse vocally more and more, including in online communities and including in online games. What I didn't know is that people are not always very nice to each other in games, and well, to the point where it's not funny. There are people who are totally not nice. I was going to say something different to other people, and that's a big problem. So if you have a problem with abusive behavior, harassment in a community, then as a game publisher, you have to do something about it. In fact, in more than half of competitive games, I think it's Overwatch, I'm not entirely sure, in a large game that is quite popular at the moment, more than half of the games lead to a complaint, lead to a report by a player who says, well, I've been harassed, I've been abused in that game. And so when this happens, there's someone who needs to review that conversation to understand if and when there was something that was abusive, that was toxic, and then what to do. If it's just maybe a ban for a few hours, if it's bad enough that the person should be suspended, or even worse. And that is something that is extremely hard to do because first, it's a ton of data. There are billions of hours of audio that go through the pipes of a large gaming company that we work with every month. And that's not data that is easy to sift through. And this is what we've built a pipeline for, essentially. So tons of audio, but also the behaviors you're looking for are often hard or impossible to capture with ASR, with speech to text, because it could be screaming, it could be kids screaming on a game. And that's not something that you can easily transcribe. And in addition, we can do on-device processing. So if needed, we can embed if you're playing on your mobile phone, for example, we have an SDK, a software development kit that you can embed directly in a mobile app, so that the audio never leaves the device. It is processed on the device. And then if there's a toxicity alert, for example, if someone is being aggressive, abusive, then you'll have something that pops up on the device and says, for example, mute for 5 minutes or suspend for 3 hours, etc. And we've realized that this use case is really big. Also, that it's a problem it is a societal problem. We want the internet to be a safe place for everyone. We want people to be able to express themselves. We don't want people to be harassed for who they are, what they say, etc. However, it's a thing that's really hard to make happen. And I believe that with technology, we can help to make the internet a safer and a healthier place for everyone. So that's why I'm excited about this use case.
It's interesting. I think Clubhouse had some problems with abuse and things like that, and various people joining rooms and kicking off and this, that, and the other. So I think that something like this, especially when you're dealing with younger like kids and stuff like that who are just kind of having fun or whatever, and then all of a sudden there's harassment and all this kind of stuff. It's not a good call. You kind of had me think of something there when you were talking about working on the edge, being able to run on device and all that kind of stuff. And I was thinking about in the voice assistant space, whether it's a smart speaker or a phone call that's made, or any kind of any place there's an automated conversation happening, you've got potential for a tool like this, which is the speech, the sentiment analysis and stuff like that, detected emotion and things like that. You inevitably have to have some kind of NLU in there to determine what it is that people are actually wanting from you. And there's different versions of that. There's the ones that you kind of explained that Amazon and Google provide, which is speech recognition translated into text, run it through an NLU. There's also other technologies that like your likes of ReadSpeaker have, which pretty much run the NLU on the audio. They might do text to speech as a backup, but it's the predominant kind of intent detection is just running from the audio. But then you've got other potential in there, which is maybe you've got kind of biometrics and authentication. And that's another question that we have coming up, which will be around the differences or similarities between those two things. But because there's so much data in audio, there's so much data in spoken words and spoken language, a lot of which we've covered in this chat, is there a potential for there to be, a lot of processing power, a lot of delay, a lot of lag in the interaction when you start coupling all this stuff together, or is auto almost unnoticeable in terms of latency and power and time it takes to process this kind of stuff?
That's something that so yes, audio is significant or produces a significant amount of data. If you think of audio that is encoded on 16 bits, so 2 bytes, 16,000 times per second, that's pretty standard. That is still 32 kilobytes per second. So it is quite some information. And if you don't process it fast enough, it keeps accumulating. So that's something that you have to do fast. And so we've built our systems to be designed for real-time processing, but also over time, and using this end-to-end deep learning platform or techniques that I was referring to earlier, we've also made sure that they are really, really fast. So on a standard laptop, consumer laptop, you can process audio using negligible power, so at hundreds of times real-time speed, which means that if you were to do a real-time processing, if you were to run real-time processing, you'd use less than 1% of your CPU. You can do this on larger, like beefier data center hardware. You can do this potentially thousands of streams on a single machine. And also, if you're doing this on your phone, you can run the audio processing with negligible draw on the battery, and you can do this on the side while you're running another app. So you could have a game, for example, that is drawing lots of power, and the Auto SDK in the background that processes what is being said and might raise a toxicity alert, for example, but that has a very negligible power consumption. And that's something that we optimized for early on, and we're happy today that it works well and it's quite fast. So the order of magnitude is that it depends, and there's many different ASR systems, but typically it takes 10 to 100 times less compute power to do feature extraction, so the deep tone biomarker extraction that we do compared to traditional ASR.
Interesting. That's pretty quick.
Very.
Yeah.
So maybe I know we only have a... Oh, sorry, go ahead, Ken.
Not going to insinuate.
Yeah, absolutely. So I know we only have a handful of minutes left, but let's. One of the things that we always like to ask about is stats, and you brought up a few of them. But let's say that we're a company, let's say a call center especially, and we wanted to integrate your technology. What kind of lift or what kind of impact and even what metrics should we be looking at when it comes to this kind of technology?
So the first thing, there's lots of things you can do, and we always say we advise our customers to start with the simplest things. So I would advise them to first try our demo. We have an interactive demo at demo.auto.ai, which they can try, and then they can register for a free trial of the API, basically so that they will take some of their recorded conversations, their calls, and then throw it into our system. They don't have to install anything. It runs on our end. And then they will get insights back. And we advise looking at things that are quite simple, really, but sort of speech time, that's super important. How much the agent speaks versus the customer, what is the dynamics of the interaction, how many music breaks there are, or music holds, because if someone is being put on hold for 3 or 4 times, that's something that you'll hear in the recording of the conversation, and correlate this to an important metric for call centers, which is AHT, so average handle time. And you'll see that there are some striking patterns in which there's very simple metrics like again speech time, or the dynamics of speech agent to customer speech gives you very important insights into how well your call center is doing. So that's something that we typically advise our customers to do first, and then as they build more analytics power and they get more familiar with the insights, then they can go into the emotions model, the arousal model. So in order to understand how agitated potentially their customers are, how engaged their agents are, and correlate this with the first metrics that they computed to build on a stack essentially of insights. And then even further, so they can train customized models based on our data, on our features and their data. They might have NPS is a tricky thing, right? The measure of satisfaction is going to depend from customer to customer, from language to language, from context to context. So typically we don't have an all-in-one NPS model. That wouldn't work. But after a while, when our customers become more familiar with the insights, the analytics that they can do derive from our features, then we advise them to build a customer satisfaction model and to deploy the tone coaching widget across the agent population, etc. So sort of start from very simple and then build up in complexity. But often, surprisingly, it is the simplest things that bring a ton of value.
I've one other question before we wrap up, which is on you. So Auto is able to gather a lot of data, process it very quickly, and draw out a whole host of really valuable insights. And because you've got such an understanding of the spoken audio and the data that's held within it, what is the differences or similarities in what you're doing to detect kind of emotional states versus what would be needed to be done to actually detect that somebody is who they say they are? So, for example, voice authentication, voice biometrics, is there any similarities with that and what you're doing? Is that something that Auto either can do or will do in future, or is it a totally different ballgame?
Actually, it's very similar. And the deep tone is built on top. So we have these pre-trained models like emotions and arousal and gender. But these are trained on top of an underlying model, which we call the identity model. And that's really the core innovation in the core intellectual property that we've built. And it's a model, and again, a neural network that tries to derive the voice print of a person. So basically what it's going to try and do is there's two samples from Kane's voice. It's going to try and pull them together, and then a sample from Kane's voice and one from Dustin's voice, and it will pull them apart. And it does this on millions of samples. And over time, it builds a good understanding of what is a voice print, how someone sounds like. And this is what we use, this latent space, so this abstract feature space, in order to train the other models. But we can tap directly into that underlying model and do biometric applications. So speaker identification is something that we can do, but then again, it's a problem that is largely solved now. It's not as hard as the other problems. Something else that is related is what is called diarization or speaker separation. You have a mono stream, and there's two speakers on a stream. And knowing who speaks when is actually a difficult problem. Knowing who speaks when in real time is an even harder problem. And we've built our diarization algorithm so to separate the speakers in a way that it can be executed in real time. So lots of applications on top of the latent, besides the latent states like emotions, lots of applications that have to do with the identity. So who speaks and who speaks when.
Interesting. Yeah, excited to learn a bit more and roll my sleeves up, Dustin. It sounds like a pretty impressive piece of technology.
Yeah, it really does. Seems like you can do a lot with it and make your voice applications go even further.
Absolutely. And so if you're interested, I just encourage you to look at our website. We have a demo online again. We have documentation, and we've decided to adopt a WYSIWYG, so what you see is what you get approach. We advertise it the way it is. We allow people to try it. And so it is AI, of course. So sometimes it works really well, and there are cases in which it won't work as well. But we try not to be too mysterious about this, and we allow people to try it. We allow people to try it for free. And then if they find value, then if they want to discuss applications to build on top of our product, then we're very happy to do this.
Cool. Fantastic. Well, Nico, this has been an absolute pleasure. You've mentioned where people can go to try the technology. Where can people kind of follow you online and follow the work that you're doing if they did want to do so?
Oh, well, there's auto.ai, and then I'm on LinkedIn. A bit boring in terms of social media. I'm on Twitter. And as of 2 days ago, thanks to you, Kane, I even joined Clubhouse. So I haven't actually used it yet, but I think I'm about to.
Indeed, we are about to. We'll hop over to Clubhouse and have a bit of an after show session. So if you are on Clubhouse, you can follow me at Kane Sims. We'll be kicking off a room in just a moment with Nico. Next week on the podcast, we are talking to Derek Roberti from Cognigy, and we'll be talking about the Cognigy platform and how you can use it to get started with your conversational AI strategy. Nico, this has been an absolute pleasure. Thank you so much for joining us. It's been wicked. Thank you all for tuning in, and we'll see you on Clubhouse in a moment, or if not, we'll see you next week on Thursday night.
Thanks, Kane.